Hello everyone, Naderza here, and in today's lesson we are going to learn how to model the landscape walls on the steep terrain. We are going to learn how to model these walls, how to model their footing, and how to calculate the cut volume of the terrain. This lesson is meant to teach you how to handle these steep terrains and how to model on them. So let's begin. Here I have one terrain modeled and I have the plot line, and the first step is actually creating the graded regions. In Massing and Side tool, I click on Graded Region tool and I click on Create a new topography exactly like the existing one. I click on this existing terrain and now the second topography is created. Essentially, we do this because we want the full calculation of the cut terrain in the place of these walls and these footings. I have created the very detailed lesson on this topic, so if you want to check that lesson out, I will post it in the description below. Of course, if you don't need calculations and if you just want to model without creating these schedules, you can skip this step. Once I have duplicated this terrain, I select the upper one and I make sure that the face created is new construction and the face demolished is none. I will then hide temporarily this terrain and I will select the one underneath it. In the face created, I will assign it the existing face, and in the face demolished, I'm going to say the new construction. Essentially, that means in the new construction, it's going to be demolished. That means once we generate these schedules, this existing terrain is going to be there and exist there only for the calculation of the difference between the new terrain, the one with these walls, and the old terrain. I also go to the phasing of this view and I make sure that I only show new. This is because I want to hide this old terrain because I'm not going to be making any modifications on it. I'm just going to be updating this new terrain. So that's why I had to filter out only new elements so I don't accidentally make some modifications in the old terrain, which is supposed to be untouched. So once I have done this step, I am going to create the wall. I go to the wall tools and I'm just going to create some concrete wall. Let's say, for example, this 300 millimeters one. I will go to edit type and I just have to see the structure of the wall. I make sure that this layer is set to be structure and the material is set to be concrete. And I'm also going to change the cut pattern to be diagonal crosshatch 1.5 millimeters. I click OK. And I also change the display level to be fine. So I will make sure that the location line is finished face interior, so I am within the boundaries of my plot line, and I'm just going to create this one wall on the edge of my plot line. I'm going to take this work in progress section and I'm going to cut right through this wall. I go to that section to see how the wall looks, and now I can see that I have placed it a little bit too high, so I'm just going to get it to be like this. For the upper height, I'm just going to lower it a little bit. So our goal today is actually to create the wall that is sticking outside of the terrain for example, 1 meter above ground. And the reason why I created this section right through the wall is because I actually want to see the precise limits of my terrain. So I want to see exactly where this wall cuts the terrain. And if you don't create this section right through your wall, you are going to have the terrain upper line a little bit imprecise. So that means it will not give you the exact outline of the terrain. So in order to actually have this precise view of the terrain, you simply create this section to go right through this wall. So once I go back to this section, I select this wall and I go to the edit profile. I take the wall tool and I assign the offset of 1 meter. As I said, this wall is going to be sticking outside of the terrain exactly 1 meter. So I create the line over this terrain as precise as possible. You don't have to follow each line precisely because, as we can see, this portion of the terrain actually contains a lot of different lines that are not perfectly aligned with each other. It is basically not the same one plane, but what we need is actually to not cut our wall too much we do need to actually hold this direction as long as it's possible. We have the very sharp sloping here, so here we actually create these different lines. Now that this is done, I simply trim these edge lines and I delete the upper line. And this is how it looks on the upper line of the terrain. But before we continue with the lesson, let's hear a word of a sponsor, which is also actually me. As you know, I have built a course where I teach you how to go from the basics or intermediate level all the way to the advanced level, where you are able to produce the entire Revit project all on your own or in the company in large teams. In this course, you aren't just watching videos, but you're actively doing exercises that are designed to level up your Revit skill. Each exercise contains the comments panel where you can actually ask questions, and I answer all of these questions the same day. Whether you are a complete beginner or you are transitioning from the AutoCAD or you are the intermediate user of Revit, this course is designed to give you the confidence to start working in Revit fully independently or in the teams. You can check out a list of lessons on the Beam and Tonic website, and I hope to see you in the course. So let's continue with this lesson. But we also need to draft the bottom of this wall as well. A lot of people make mistakes by simply cutting this wall in many other pieces and then adding them the footing. Basically, that is the slower way. The faster way is actually creating all of this as one wall. That way you can automatically add the footing to each of the planes that you have in the bottom of this wall. So that's what we are going to do today. And when it comes to the depth of these footings, essentially that is very depending on the regulations in your country, and that is something that the structural engineers are going to be calculating. So as architect or landscape designer, it is not something that you are going to be deciding. It is fully within the scope of the structural engineering and the structural calculations. Where I live, the minimum bottom of the footing is 90 centimeters. That is not the bottom of the wall, but the actual footing beneath that wall. So I'm going to draft something that is roughly like that. But like I said, this is completely in the realm of structural engineers, so don't take my advices for anything related to structural engineering. This tutorial is only meant to be the modeling lesson. So essentially, if we are going to be taking the footing that is 400 millimeters thick and our minimal depth of that bottom of the footing is 900 millimeters, that means we are going to have to offset the bottom at least 500 millimeters. Of course, I don't want to be within these minimal values. I do want to actually go a little bit above the minimal values. So I'm going to take, for example, 700 millimeters. Of course, like I said before, don't take these values to mean anything. This is very related to the type of soil, to the country you live in, to the regulations, etc. So I take the line and I make sure that the offset is 700 millimeters. And I will start from this first part. I make sure that it is offsetted for 700 millimeters below the topography. Some of these lines are going to be too big, so we are going to return to them and we are going to update them. Here I will also do the same, and I draft everything this way. I now connect these lines, and I also trim these edge lines. I delete the bottom one and I make sure that I don't have gaps anywhere, like here. I just trim that. So now a couple of these seem a little bit too deep, like for example this is 2.5 meters deep and this is 2.4 meters deep. So that means maybe we should split this part in half. So here in the half of this line, half of this value, I will also offset by 700 millimeters, so I have a little bit less sharp steps. So I trim them once again, and now this seems a little bit better. And I will do the same here. Even though this distance is very short, it does seem a little bit too high. So I will also find the middle, and I will also define the offset of 700. And I will make sure that I draft this line like this. And this also seems a little bit better. Like I said, I'm not sure if these depths are correct, and this exercise is for modeling only. So once I click OK, this is what we get. And now let's add foundation to this wall. I will isolate this wall and I go to the structure option and I go to the wall foundation. Here I choose which foundation I want in the edit type, or I create the new one by duplicating and assigning the different width and thickness. I will duplicate this one and I will create one that is 1000 millimeters per 400 millimeters. I click OK and I assign these values. And I click OK, and now I simply select my wall. And as you can see now, all of these foundations are automatically placed. I don't have to go one by one, I can simply create these foundations in one click. This is very useful tip because it can save you a lot of time, especially if you have a lot of these walls. Now I go to the plan and I create one section to see what it looks like. I will just hide this existing section so it's not in the way, and I will make sure that the detail level is set to fine so I can see these textures properly. And this is what the footing and the wall look like now. And the problem here essentially is that it is not cutting the topography. So I will now create the schedule just so we can see real time how this topography is going to be calculated. I go to the new schedule option and I will choose the Topo Solid. I give it a name and I click OK, and the next thing we do is we add the cut option just so we can see how much of the terrain is cut, and I will also add the name. I will just push the name to the first place and this is what it looks like. Since the phase filter is set to show new, we can only see the new terrain, and now we can see that our cut volume is 0. That means we still have not cut anything, and in order to cut this wall we go to the cut tool and we click on topography and then we click on the wall. We do the same for footing, and this will actually automatically cut all of these footings. And now when we go to this Topo Solid schedule, we can see that actually 25 cubic meters are actually cut from our first terrain. And what this section misses right now is actually the gravel. So I go to the plan 1 and I will just hide this terrain temporarily just so I know the shapes of my gravel layer. So I go to the floor tool and I have created the gravel family and I will just create it to look like this. I'm not sure what is the height of this gravel, so in this section I can just move it to be below my footer. We can also do this the easier way and the faster way by going to the floor tool again and just create each of these gravel layers separately. It doesn't matter for now the height because the height is going to be quickly added later once they are all modeled. And once they are created, I go to the 3D view, I hide this terrain, I hide the old terrain as well. And all I do is I use the align tool. So I grab the bottom of the footing and the upper plane of the gravel. And that way I can quickly get them to be on the right height without having to actually go to each of these sections. This one I will just get to be like this. And this is what it looks like. Essentially now we also have to cut the topography in the area of gravel. We can also do that in the 3D. I'm just going to get back this topography and I'm going to select this wall and I'm going to use this selection box to get it to look like this. Essentially this way I can see right away which of these gravels are not actually cutting the topography. So I take the cut tool and I first click the topography and then the gravel. And I do this for each of these layers. And now it is done. Everything is joined, everything is cut. And once I go to my schedule, I can go to the Topo Solid schedule and I can see that the volume of the terrain that is cut is actually 35 square meters. Once I hide this topography, I can see what this wall looks like. And this is essentially how you model these walls in the steep terrain. And this is it for today's lesson. If you liked it, like and subscribe. It helps my channel grow. And thank you for watching, and see you in the next lesson. Bye! If you want to learn Revit like a pro, take a look at my architectural course through the link below. You will learn how to develop the project from concept to final design using Autodesk Revit. It is ideal for beginners but valuable for anyone looking to build a solid foundation. By the end, you'll know how to take a design from concept to detailed documentation with confidence and clarity. You will gain a solid Revit workflow you can actually use independently or in work in larger teams in architectural studios. With almost 100 structured video lessons, it is designed to help beginners master Revit step by step. To support your progress, I've included assignments with each lesson, plus the opportunity to ask questions and receive guidance directly from me whenever you need it. This way, you're not just watching tutorials, you're actively learning, practicing, and improving every step of the way. Thank you for watching, and see you in the next video.